Pascal's law. Pascal's law has to be elaborated at length, but before that, let's revise again that hydrostatic pressure depends only on the height of the liquid column. It doesn't depend on the shape, area, or design of the container. That's not going to affect the hydrostatic pressure. It's entirely dependent on the height of the liquid column. You see, Pascal, a scientist, he contributed a lot in hydrostatics and dynamics. On his name, this law is based. He says that whenever on enclosed fluid, remember this law is applicable on the enclosed fluid, that's enclosed from all around, means there is no freedom to flow. You apply pressure at any part of the container, or you might say the liquid enclosed, the pressure that you applied from outside will be transmitted immediately unchanged throughout. Listen again. Whenever pressure is applied on any part of the enclosed fluid, that is transmitted undiminished, unchanged, unreduced throughout the container. Means, if you are applying the pressure over here, see, suppose in this very arrangement that's filled with water or any liquid, suppose it is a movable piston and you apply a force from this side, a force. That means you have applied the pressure. This pressure will immediately be experienced over here also, means you have pushed this piston downward. Obviously, this piston will move a little away, that is outward. This is what exactly Pascal's law is. Once again, I'll repeat, whenever the pressure is applied on enclosed fluid, it is transmitted unchanged throughout the container. Now, you might ask me, suppose by another example, I'll just try to elaborate. You see, this is horizontal pipe having the two vertical ends which are unequal in size. Here, this is filled up to the brim. That means up to the top it is filled. But since this is a bit longer, some part is open. You see, soon as the water or any liquid is poured over here, it is poured over here. Suppose it is a colored liquid. It will immediately flow, no doubt. It will overflow because it was filled up to the top. So, when you added some liquid over here, the level will get disturbed, the level will be unbalanced. In order to balance the level, it will overflow. Now, you might ask me, with what speed and what travel to this end? Actually, water color, it will remain over here only. Something has been transmitted to this end, that is what we call electromagnetic force, electromagnetic pressure, and that traveled with the speed of light. Soon as you will pour the water or liquid, immediately at same very time this will overflow. So, when you are trying to understand Pascal's law, you also understand this thing, that pressure is transmitted unchanged. That pressure gets transmitted with electromagnetic speed, and to any part of the container, it will be experienced immediately. Now, with this Pascal's law, we have so many applications in our practical life. For example, here you see two vertical columns filled with liquid. Both are dissimilar in their cross section. One is narrower, other is wider. You see, F1 upon A1, this side is F1. I have put some weight on the movable piston, some load, some weight, F1. F1 upon A1, that is the pressure here. But you know, same pressure should be experienced throughout the liquid. Same pressure will be here also. Now, it means F2 becomes F1 A2 upon A1. F2 is the weight that could be lifted this side. You are putting the load over here. with the ambition to raise the object, heavy object like car, truck. You want to lift it up, you want to push it upward. So F2 is a force needed, and this can be increased only by increasing A2, or you might say by decreasing A1. So what's advisable here is that you take this tube narrower and take this tube wider. More wider the tube will be, more load could be lifted by this side. No machine, no chain, simple water and two weights. But this thing, this whole arrangement is known as hydraulic lift. With this help, with its help, we could raise many heavy trucks also. And similarly, we have hydraulic brakes, hydraulic jack. These are hydraulic press is also used for in printing industry. Many instruments are based on Pascals.